All right, number 6 right here, it says circle if the function is either discrete or continuous for the given domain. Continuous means it's going to include all the numbers in the interval. And you can see right here, it just says x is greater than or equal to 6. So that's a pretty big interval of numbers, going from 6 all the way up to, I guess, infinity. And so that would be considered continuous. Anytime you have the inequality symbol there and it says nothing about just include the integers or just include the rational numbers or something to that effect. So this will be continuous. And discrete would be just like individual points. So it might say x equals 3, 5, and 10 or whatever. For the range is all the possible y values. So I'd have to plug in all the possible x values. So of course x can be 6. So let me plug that one in first. So I plugged in 6. Since you're dividing by 6 and multiplying by 6, I let those cancel. And you're left with a statement that reads y equals negative 5 plus 5. So in the end, y will equal 0 here. Now the range, like it says, it's a continuous graph, so it wouldn't make any sense to say that the range is just y equals 0. We got to keep going here. X could be 12, x could be 18, x could be 7, x could be 8. Obviously all the way up to infinity, like we said. I'm going to plug in 12, and the reason being is that I've got a fraction here, and I think by using 12, it's a number that's divisible by 6. They have a common factor. And so it won't get quite as ugly in terms of getting out integer answers. You want to get integer answers out of here. We're just trying to test points to see what works and what doesn't. So I'm going to cross reduce. That's a 2, that's a 1. And now it's negative 5 times 2, which is negative 10. And add that to 5. That's going to equal negative 5. So we've got y equals 0, y equals negative 5. And this is possible because we said that x just has to be greater than or equal to 6. So if x is 12, that's a possibility. On the other hand, if you look at 0, and I like using 0 just because 0 is an easy number to do math with, and when we multiply here, the coefficient negative 5, 6, it becomes 0 because that's what you're multiplying by. You're just left with y equals 5. But like we said, x can't be 0. It has to be greater than or equal to 6. So this is not a possibility for your range for y to be 5. So this was, I think, the extreme. 0 was an endpoint because we said that 6, your domain, was an endpoint. So therefore, we're going to say y is less than or equal to 0. This number right here works, and that's less than 0. This number right here doesn't work, and that, of course, is greater than 0. The reason that you'll notice the sign right here flipped is that we were multiplying by a negative coefficient, and any time that you're multiplying or dividing by a negative, that's going to cause your inequality symbol to get flipped around. Number 7, this time you have a discrete domain, and what I would have to do is plug in negative 4, negative 2, 0, 2, and 4. And if you notice, the change in x is constant here, and we've got a equation written in slope-intercept form. So that means this is a linear function if it's in slope-intercept form. So we can expect there to be a pattern in what we get out for our outputs here. This will equal 4 over 2, which reduces to 2. And so your output is 4, or your range is 4 for that particular input, negative 4. I'm going to test it again. This will equal 2 over 2, which is the same as 1. And we get y equals 3. I'm just going to do one more here. Let me use a different color. So this is a messy 0. It looks like a 6. That's an issue that I always have had, even going back to when I'm a student. So just keep in mind, that's not a 6. I just write messy with my bamboo pad here. But y equals 0 plus 2, so y is going to equal 2. And you probably notice a pattern that y is changing by 1 every time. And that actually directly relates to the slope. Remember, slope is change in y over change in x. So since x is changing by 2, each time, we can assume that y is changing by 1, and that's why we got 4, 3, 2. So you can probably predict when x is 2, y will be 1. When x is 4, y will be 0. So your range, the final answer for the range, is that y is equivalent to 4, 3, 2, 1, and 0. Very important when you check this that you have 5 values for your range. You should also have 5 values over here for your domain. If you're missing one, something was off. All right, write an equation in slope-intercept form. I just mentioned slope-intercept form. It's y equals mx plus b, where b is the y-intercept. If you notice, the graph is going through y right there at 2, so I would write plus 2. And then m is the slope, so you could pick any 2 points. I'm going to pick that point that I already have a dot for, and maybe this point right here. Looks like we're rising 1 and running 2, and we could have done that anywhere on this graph. Rise 1, run 2. We could even do this. We could say I'm going to rise 2 and run 4. Rising 2, running 4 is the same thing as rising 1, running 2. So your slope is 1/2, and then we have x here, so y equals 1/2 x plus 2. Identifying the domain and range. I'm going to go a little bit faster here, but the highest point is 9, so that's going to be part of your range, so I'll start with that. So your range has to be less than or equal to 9. And then if we scroll down a little bit here, you can see the lowest point is 1. So y is going to be greater than or equal to 1. And so that would be your range. Your domain would be pretty similar to that. X is going to be greater than or equal to -3. You can see that we're counting by ones here, so it's going to be a -3. And then we're comparing that to the value of, it looks like this is the low point for the x value, 1. So I'd say that x has to be less than or equal to 1.